Christina Lin is in charge of DevRel at Redpanda. We talked today about their new feature that allows you to run stateless transformations in WebAssembly on the broker. This is another interesting take in the eternal debate between tightly coupled and loosely coupled storage. And honestly, I think this is a really cool story. And Christina talks about, honestly, a fun use case that I was just delighted with. So this is worth a listen. Jump in. Let's listen to me and Christina talk about WebAssembly and Redpanda. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined in the studio today by Christina Lin. Christina is in DevRel at Redpanda. Christina, welcome to the show.
Thanks for having me, Tim.
It is great to have you here. I want to talk about Redpanda and stream processing and WebAssembly. And first, what is WebAssembly?
Well, WebAssembly is just another bytecode format. So basically, you write a piece of code, you compile it. Like what happens in Java, you compile into like something that JVM understands, and then this gets into some kind of bytecode instructions, and your computer will then just execute based on the instructions that it compiled into. So WebAssembly is the same thing. It's a bytecode format that your computer understands, and they'll execute based on that. But what is that to do with brokers? And when you hear about WebAssembly, people often associate with this thing of, hey, it runs on a browser. What is it do?
Yeah, before we get to brokers, I want to ask. So it's a bytecode format, and so there's some virtual machine somewhere, and that runtime, classically, traditionally, in the origins of WebAssembly, that runs in the browser. The browser is executing that bytecode, right?
Yes.
And it's got some security model where it can access things in the world. And I hear about cool things being done in the browser, like C++ code being compiled to WebAssembly and native speeds and blah, blah, blah. So it's cool.
It's really cool because I think it does a couple of things really well. People talks about, the sandbox execution. So it takes care of the security. So basically you bring up this VM. This VM sits on top of your hosting environment. So you got this isolation of execution environment. So it doesn't go outside of what it's supposed to do, right? So the security things, it gets, taken care of. And then another thing is its performance, because it is more of a bytecode, and then it's like a bytecode formations, and the engine actually talks directly to the computer. So it's more like a native way of, the execution speed is a lot faster compared to the traditional way of, you have to interpret it and then move it to the execution part, whereas so the performance is a lot better. And another thing is it's polyglot. It's similar to what Java does, right? The JVM, you can write Java, you can write Scala on top of things. So like write in different forms and you'll compile and execute, right? So that polyglot extends it to a little bit like wider to a different audience, right? So you can run, your Rust, your Go, your Python, your Java app, all that kind of stuff, right?
All those can be compiled into the WebAssembly actual, and it looks like an assembly language.
Exactly.
And just like with JavaScript, which originally was a runtime that existed inside the browser, and then that runtime escaped the browser, and we had things like Node.js.
Right.
WebAssembly, same thing. You just pluck that runtime and put it other places, like, I don't know, a Redpanda broker.
Right, exactly. So I think before it was kind of plugged into the JavaScript runtime, like what you said before. But now we're trying to get that running outside of the browser itself. So that's why we're using this thing where it is going to have this native interface, where this native SDK, where it can talk to your native computer language, so it will interact with your operating system. So instead of doing things inside the browser, now it to interact with your machines instead of like just running it like on the browser. So you can have it in different places, and that's where we extend it to, and then that's why we put it in the browser so it can start working there.
There you go. Or in the broker, you mean?
In the broker, sorry.
Yeah.
Sorry.
Started life in the browser. Redpanda now entering the browser wars, which are going to happen again. No, folks. No. It's in the broker. And so, so, the way, I remember when I was new to the Kafka world, this would be like 2017. So a lot of years ago, 7 years ago now. Yeah. So, and I was first learning about things like Kafka streams, or even just I guess I had already known what a consumer and a producer was, but like really starting to think about stream processing.
Right.
And there's this priority in Kafka proper that the broker is dumb, and that's an intentional, and I think there's wisdom in that, right? It's a hard problem, and like just focus on this one problem. And if you're going to do computation over messages, you get those messages over a network somewhere else, and you move that state, and then you do the compute over there, and maybe you replicate it so you've got local versions of it, and there's all kinds of layers and sophistication that grows up around that. We've talked about those things on this program. We'll put links in the show notes to Kafka streams and all that stuff, and basic Kafka episodes if you're new and you want to study up on that. But that's the approach: is the messages are stored in the broker, the log is stored in the broker. We want to move them to some other system and do the compute there. Which is, I think,
it's a different thought of mentality, right? So
yeah.
I started doing messaging back in the days when I was doing IBM MQs and Revit MQs. And, at the time, brokers are a little bit intelligent, but I think their intelligence lies in the way that they store their messages, and they will process a little bit into the messaging and then understanding where to put them, where to store them, where to delegate them, and all that kind of stuff, right?
But how to route them
to the different places. Exactly. So there's not a lot of business or transformation logic even at the time, right? And then when we come to the Kafka time where we want to go high performances, things go a lot faster. So you want to keep doing your logging instead of, doing all that, looking into the messages and then process it, right? So that's a different thing. But now when we are doing things in Redpanda, because the way that we write our architecture, so the way we did it is that we have this thread core architecture where all our threads are now like in charge of a certain segment of the memory, right? So it's doing its job, it's writing it. And then a lot of times that we found a lot of our customers, their browser is not at 100% capacity, right?
Broker.
Oh, the brokers, right? Sorry. So what am I doing today? I'm sorry.
Well, we started talking about WebAssembly.
Sorry. The brokers are, they're not at their 100% capacity, right? So
right.
So we have this thread sitting there, and they're waiting for the messages to come in. They're not doing anything at all. So what we're thinking is, if it's sitting there, why can't we just do something? Because we're the closest to the streaming data that came in, right? And if you want to do some pre-processing of your data, the just-in-time processing of your data, this is the perfect place to be.
Because the broker was I/O bound and not compute bound. There was spare compute resources.
Exactly. At the time, it was I/O bound, right? But now we have this all, SSDs and this really fast mechanism of accessing your disk. So I think currently the boundary is never the I/O anymore. It is the CPU cores, right? So that was why when we started doing performances benchmarking with Redpanda, we can see that the problem is no longer with the fast disk writes, right? Because XFS make things store a lot faster. You can store things in parallel, right? And then the way that the machine delegated and stored data it's in the matter of milliseconds, right? A very, very lightning speed, right? So no longer you have this disk of this pointer where you're writing things in the disk. That longer doesn't happen anymore. So that's why it's never the I/O bound, it's now the CPU bound. But since there's not a lot of traffic going on inside the CPU, there's a lot of resource that's wasted. It's doing nothing. So that's why we were thinking, if it's wasting its time, why don't we just do some processing? Traditionally, the processing happens outside of the broker. And when it happens outside the broker, there's a couple of things you need to do. First of all, you need to actually pass the information outside of your broker. So there's an I/O, networking I/O, that needs to go outside of broker and then sends it to a different place where it is then that other machine needs to take its CPU cycles, reading from the network, putting into memories, and then start processing things, right? So these are all the things that was wasted to do a very simple transformations. So that's why we're thinking, if we want to do these transformations, do this real quick transformations when the bytes just touch the machine itself? Why can't we just do a transformation here? And that is why we added this WebAssembly engine inside the broker so that it will start the immediate transformation right away when it hits our thread.
There you go. Because you saw that typically there was compute, unused compute that you couldn't. I don't know what the. I don't know what if you know what the rate limiting factor was.
Right.
That was keeping that from being utilized if it wasn't I/O, but it wasn't. You had spare compute there.
Exactly.
And you figure, why not use that? Why not have a way of putting some code in there?
Exactly.
And of course, there are some why nots, right? It is a trade-off, but it seems like WebAssembly is a way of addressing some of those. And
yes,
I'll just
100%, 100%. Because if you think about it, all the browser knows, all the broker knows know about it is your own data that goes into the broker, and that's all it knows, right? So it doesn't know much of the complex business things or any histories that or any external informations outside the broker itself, right? So if you're looking to transform something and say a data enrichment, you're probably not going to do that with those type of transformations inside the broker. Doesn't make sense because you still need to get the data externally outside and put it into the broker and then does the transformations inside and put it into a different topic. So you're losing that edge of, hey, I'm processing right away. So these are typically not a good place if you're doing a WebAssembly transformations inside a broker. But these are probably do it outside the traditional way. But if it's something that's really quick, something like masking or transform your data shape, transform it from JSON to YAML, transform it, or just filtering some of the content inside the message. That's a great way to do it, right? So you're not.
Can they be stateful?
It cannot be stateful. That is one. I think this is a very good stateless situations where if it's coming in, you need to process it like quick processing. This is where it does. But stateful, anything that requires memory, that requires a long-term memory, I say long-term memory, a long-term state memorization and learning where things coming from, then it's not a good place for it to run.
Okay. So you're saying you're going to let some complexity come into the broker, but state, you're going to have to then yes, move the state across the network and go do that over there. Maybe still in WebAssembly. It's the kids like it these days, but not. Yeah.
Exactly. I think this is a good edge case because a lot of our use case will coming from different edge devices. So normally what we have is, edge device that has a small broker, a very lightweight broker that lives inside to become the buffer. And when you have the signal coming from the sensors, the signal comes in different flavors, different informations. And if you want to clean up sensor data before it hits, your centralized data center, you can have that little quick filter code or that transform code inside your edge device and have it delegated to your data center, right? So that's I think there's a different ways of using it and different things. It's more suitable for this kind of workload. So it's just one of the typical things I see people use it for.
There you go. What's the developer experience like? So walk me through. It feels like this would. I'm asking for live coding or a screencast or something, but without that, assuming folks are just listening, what's the API look like? How do I write? How do I deploy?
Yeah, that's a great question.
Am I writing in native WebAssembly or can I write in the language of my choice? Talk to me about the whole workflow.
That's a great question because I think people like this idea of having WebAssembly, but they don't know how to put their code into the broker.
Sure.
So that's why
my second language was assembly language. I've learned BASIC and then I learned 8086 assembly language. So I'm fine with that. But like most of us don't write business software in actual assembly language. It seems like, a strange practice.
I love assembly, by the way. It's my favorite one because it's more logical.
Yeah. There is just no BS at all.
Right.
But writing business software
requires
in assembly
a lot
language
more.
is kind of ascetic. It's like, I'm going to go live on top of a pole in the desert for 30 years or something. It's just not a thing that most of us decide.
You can't really just do like moving your bytes or like do a plus and minus and all that kind of stuff, right? So yes. So to do that, we have actually make it simple. So we have this tool called RPK. This RPK tool was used to interact with our browser. So it naturally communicate to our brokers, and then it talks to the broker, and then it kind of just do some admin stuff normally at the at the beginning, right? So we use this RPK tool to do a 3-step. We kind of put in 3 steps. We do RPK init, so it will then initiate a folder structure of what your code is supposed to look like. So we'll give you some example
development
code
tool on the development side,
right? So basically,
scaffold it.
Yes, you basically download it and it will bootstrap a folder structures where you can scaffold like all the things that's available inside. Currently, we support Golang, and then we also support Rust. JavaScript is coming on the way. The reason why is because Go and Rust is just a lot easier when it comes to converting it to WebAssembly code, because interpretation code is a little bit more difficult in terms of turning it to assembly.
And Go and Rust, we could say, sort of culturally are more tightly coupled to the WebAssembly world. I mean, that's how
exactly.
Yeah.
Yes, and then we're looking into like putting in Python as well, and then Java.
Okay.
Right. Yes. So so what you do is once you have that folder structures, and then you can there's a example documents, and there's example file where you can start coding. And basically what you have is you have this method of, hey, I have a record. And in the parameter, it has a record of, each record is a message that goes into the broker, right? So basically you work with this particular record in your method or your function. And then you work with it. And then once you're done with like writing that code, basically what you do is you do RPK compile. So basically it will compile the code into WebAssembly code, and then you do RPK deploy and deploy this assembly code up to the broker. And what happens after that is the broker will then distribute how into a cluster. Basically the cluster has multiple brokers, right?
Okay.
So basically,
but I send it to one broker and
it will then delegate everything over to the other broker. And when it starts up, it will create this very small virtual machines onto each thread, because Redpanda is a thread per core architecture. So every thread would have its own little VM of this WebAssembly code, right?
Oh.
So when your data hits into your broker, every CPU, like it depends on which CPU picks up your code, right? Pick up this message, right? So and it will pick this message up and see if it needs to process. If it needs to process, it will then start processing it, right? And then writes it back to in the memory, dedicate to where it goes, and then you have your transform message.
That makes sense, and that sounds like a nice tool chain. Yeah, it's any language you want as long as it's Go or Rust, and improving that, adding new languages in the future, and sounds easy to do. And I imagine there's folks who automate. You don't want all of that to be you typing RPK deploy all the time. There's probably some artifact that you could put into your infrastructure as code or into the cloud or something.
Yeah, well currently this is like a very early phase where we're trying to get this. We do have some use case already, but I think currently we're still rely on this RPK tool to do it.
Okay.
But in the future, I think we'll have other mechanics to actually do.
That'll grow. And that would have been a good question for me to ask. I was just assuming, but this is early and a still cutting edge, advanced thing, and it's
right.
What have you seen many use cases? Can I ask you about things? Not names, but things you've seen. Like what's the most interesting transformation you've seen, and maybe what's the worst behavior you've seen? Because I'm just sitting here thinking, I could call APIs and I could do database queries, and what are the most horrible things that you could do?
So actually,
one of these?
We did put in some guardrails into the SDK itself. So you cannot really do that. And the nature of WebAssembly, you have to actually expose that into your WebAssembly environment in order to call
the security model.
Exactly,
you have to be explicit.
It is secured. Yes. So there's no way that you can do that. So that's a good thing. So actually, I've never seen any worst case scenario for now, because everybody brag about it, kind of just telling me like wonderful things that they did. So,
Okay.
the good thing I saw was the edge case I was talking to you about. Like I saw this thing where they were getting informations from this edge devices. This is
Mhm.
a voice over devices
So by
where
edge case, you mean a use case that is edge computing, not
edge
an edge
computing,
case
exactly,
of right,
IoT
right.
edge cases, right?
Yeah, yeah,
So
yeah.
where this person is going to is actually doing something over the voice, and then they have this voice message coming in, and they want to vectorize it, and then just to you know digitize it, right? So they put a
Really?
small digital. So they already have this WebAssembly digital SDK available. So basically, they just import that the into the project and then deploy that onto Redpanda. It surprisingly worked. So whenever
And there's
the
actually a model that can create
exactly
an embedding from
exactly
time series audio data.
exactly yes, it's
Okay. If you're not
I'm not
watching this
a
on YouTube, you can't see my face, and I am very pleasantly surprised. I'm just happy
yeah,
that
it
that's a
is.
thing.
That was amazing what I saw. I'm not 100% like see how production ready that was, but it was something that amazes me because that means there's a lot of things that we can do, right? So as long as we can turn this specific logic into a WebAssembly code, you can always plug that into your broker, and that makes your broker 100% smarter.
You see,
So
I just lack creativity because I'm thinking like, okay, you can mask PII or maybe, translate some formats and that data's messy. It's like, okay, this field, if it has this value, then this other thing is mapped like this. And if it's this, it maps like that. There's garbage in ingest. It's always bad. And you have to write code to make it work. And it would be better like this all makes sense, but I'm thinking like that's about as far as you go, right? You're basically running a map and filtering stuff, but no, dang it, no. You're first of all, you're putting media, voice
right,
in something like Kafka, and
right,
you're not supposed to do that, but no, it's okay. We're going to turn it into a freaking embedding
right,
in real time, message by message at the broker level,
exactly,
because you can put all that because
right,
WebAssembly, you could just have all that
yeah,
in the deployment
yeah.
artifact. That's just awesome.
Yeah, that sounds like that's really good. But the thing is, this is all like currently we're just experimenting with it. So I'd love to
Mhm.
hear if you have any good ideas, if you can have your awesome libraries turned into, a awesome bytecode that we can run. I love to talk to you because I love to, try it out and then see if I can run that in the broker. Of course, that comes with the price because, if you're ever using the CPUs inside your broker, then you're sacrificing that power to do the transformations, right? So
Right.
you for that means that you probably need more brokers to do the jobs, right? Because you're still doing some Kafka work to to distribute your data,
Yeah.
to stream the data
Yeah.
and all that. So there's a way that we can limit the usage of this WebAssembly, but that also means that it's going to be a little bit slower because you need to cut it in half. Some of it does the WebAssembly, some of it does the traditional like streaming things where it's storing the logs and putting into the disk storage and stuff like that.
Yeah. It's not. I mean, there's no free lunch. It's more. What you started with was that she's got a bunch of her fries she's not eating, and you know
Exactly.
they're just laying around. I'll take those.
Right.
It's a way. It's just an extra tool in the toolbox, I guess,
Yes.
to try to minimize the spend on compute and storage and potentially networking costs. I mean, you'd want to be smart about that. You wouldn't want to pay network egress, cloud
Right.
egress costs to get to your stream processor.
Right.
I don't think most people would do that, but um, it may still be in any given situation that you've got some really big thing and it's stateless but it's expensive and you're going to still get the data off the broker and run it over here. Maybe you want that, but
Yes.
as an architect now, it's a tool in my toolbox. I get to make the decision about whether I want to put it at the broker. And yeah, right. I mean, maybe I need 5%, 10%, 20% more brokers because
Yes.
it's computationally heavy, but I would have needed more
Right.
if I was going to move the data. I get to be an engineer,
Exactly. So you got more tools.
and that's a good thing.
Right. So, but currently we have a couple of examples that I did, just, because everybody's talking about AI machine learning nowadays. So we have some tools that, built it. I have a example that tells you how to filter your data into a trainable data where you can live training your machine learning, so you can have your model out right away instead of waiting for a batch job. But I think that's a very traditional streaming story, but it helps a little bit with, coming up the right format for your like learning data sets and stuff like that.
Yeah, and that's just it. If anybody thinks this is interesting and cool, if you could send me links to those examples, we'll put those in the show notes. And the next step is everybody wants to play with something, so those would be great to have.
Yeah, and if you ever have any like awesome libraries, let me know, because we love to have them in it.
My guest today has been Christina Lin. Christina, thanks for being a part of the Real-Time Analytics podcast.
Well, thank you for having me. I have a great time here.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.